Hello and welcome. I am here to share my journey of large language models, and particularly kind of chatbots, and integrating with various systems and kind of custom data sets. And this has really been my learning journey as of up to a few months ago. And as we move through this, hopefully you'll learn a bit along the way around how these chatbots and things are constructed. But also you can see how my own journey has progressed from sort of a basic chatbot right through to something a little bit more advanced. As you can appreciate, this is an ever-changing landscape. New things and tools and models are coming at every single day, and it's a really exciting space to be in. And I'm happy that I've gone down this journey because it's certainly opened a few doors for me. So when I set out this project, I really wanted to cover up a few things. I wanted to learn a bunch of new things, obviously, lifetime learner. It's an exciting field, exciting tech. So that was number one. I figured chatbots were the rage at the time. Remember, I started this journey sort of over a year ago, 14, 15 months ago, and chatbots were all the rage. ChatGPT had just come out, so I wanted to get involved in some of that as well. I wanted to use the Veeam knowledge base database. We'll talk about this later, about good data and some other aspects around that, but I happen to have just done a recent project around that, which is why it was a nice suitable data set for me to utilize, and yeah, we'll dive into that a bit more later. OpenAI models with RAG, so retrieval augmented generation. OpenAI models are nice and easy to consume, SaaS-based service, relatively cost-effective for what we're doing here. However, I have actually started using some local models that are presented through things like Ollama, and that space is changing a lot as well. We've got the likes of even X and Twitter and Elon have just released their model. You've got people like Zuckerberg releasing things like Llama, and Llama 3 is due out very soon. And then you've got things like Mistral and a whole bunch of other models that you can now run locally on even modest hardware, as long as you're okay with the generation times being slightly slower. And for something like this, it's absolutely perfect. So yeah, this particular project focuses on OpenAI models specifically, but really insert other models here. And yeah, the response mileage might vary, times might vary, but you can certainly mix and match various different models here. I wanted to learn about vector embeddings. This isn't necessarily something that's new because we've invented chatbots. Vector databases and things have been around for a fair while now. I knew really nothing about them. Now I know slightly more than nothing, but it's definitely an integral part of what we're talking about here and the overall technology stack of building out a chatbot, of a RAG application. And then obviously vector embeddings is critical. That's embedding our data and sticking it into those vector databases. And so again, didn't really know anything about vector embeddings before. Now I know again, slightly a little bit more than nothing, but it's again super important in what we're talking about today for us, helping to retrieve the data out to then pass context through to our models. And then I wanted to share it. I mean, I've talked about this a few times now on various podcasts and at different events, and this is kind of just the latest iteration on that. And so here I am kind of sharing my journey of it. I've learned a lot from others online, so where I can give back, all the better. And then iterate. You'll see that, going through versions 1 and 2 and 3. Yeah, it's varied a lot. So what is RAG? So we've already mentioned this. So it's retrieval augmented generation. And effectively, it just allows us to pass additional context. And what we mean by context is some chunks of text. You remember these large language models are trained on huge amounts of data, but maybe not necessarily our private data or specific data, or even up-to-date data. These are trained at a point in time. So what this allows us to do is pass those types of data sets into our language model and then kind of wrap a query around it and then use the power of its capabilities to kind of give us our response back. And that's what we're just doing here. And so that's what we've covered off. These large language models are stuck at a point in time. That's when it was trained. It's not trained on our private data sets. It's also costly and timely to retrain an LLM. You imagine if we've got private data that's coming up through our organization all of the time, we'd constantly be in a battle to retraining our own models if that's where you were going. So RAG really allows us to augment that and leverage the power of those LLMs. Sure, they'll change over time and get better as we've seen, but we can force bits of information in there when and how we need it, and it can be up to date. Look, I'm not going to get into fine tuning. My thoughts on this has actually changed a little bit, but I didn't need to. The cost at the time was expensive to fine tune. There's some new methods of doing that now, which are a lot faster. And yeah, I just didn't go down that route, although it's a space that I kind of want to start moving into next, and that's sort of part of that iteration piece. So let's take a look at what that means visually. So on the left-hand side here, where the wee question box is, that represents us typing into our chatbot. We obviously ask our chatbot, our little API, our code, a question, and what we'll do is we'll take that question and we'll talk about embeddings and things in a minute. But this is where this smart retriever down to our knowledge base, the lookup and retrieve relevant documents comes in. So what we do is we actually embed the query and then we go and look up and say, hey, vector database, what matches most closely with this user's question? And then we return back the relevant documents. And in our case, for the first version at least, I'm actually only returning back the metadata. I get the top match in my case here, and I return back the metadata saying, hey, this came from KB123, and then I can go and retrieve that. But this is a simplified view of that. And so once we've got those documents back, we can then pass the original question as just plain English, plus the document or a part of the document across to the LLM with a bit of pre-prompting, something like you're a helpful AI assistant, yada yada yada, what sort of responses we want back. And so we pass that, the question, and any documents or chunks to the LLM. So in our case, OpenAI with the wee bookworm here, and then it gives us back an answer. And there's some variables we can tweak there, such as temperature and some other things. And temperature is really a good way of saying kind of how much poetic license are we going to allow the large language model to have. So how much kind of freedom does it have to kind of make up some models? So depending on your use case, if you know you're in a creative field, you might want to dial the temperature up a little bit because you want it to have that creative freedom. But a highly technical field, we might want to dial that back down because we want it to give us very specific answers and not kind of start making things up and start to hallucinate. The foundation, like anything, any good project really starts with good data. I think you can apply this to many fields, and it's no different when we start talking about chatbots. And so we've talked about this earlier on, and really I've utilized the Veeam KB dataset. And so the challenges I had with just using the website out of the box was it's just a website with bloated HTML. There was no API. That's what we're referencing there around programmatic access. There's no index page with KB numbers. Also, the code itself, when I mentioned bloated there's a bunch of like inline forms and unwanted embedded content. They'll just kind of put our LLM off, so we're not going to get the optimal results back. Most models are pretty good at deciphering all of that, but the cleaner the data we can send to the LLM, the better we're going to get back. But it also reduces the context window too. If we're sending unnecessary amounts of content into that LLM, it's going to ultimately cost us money or take longer to generate because we're feeding more information into the LLM than we need to be. And so I needed to solve that. I needed a way that we could get programmatic access and clean it up. And so what I've built, and it's on my blog for anyone to use, and it's actually a public website that anyone can hit now, is I've got a scraping engine, and effectively I'm reaching out to the Veeam KB website and scraping and cleaning all the pages, converting it to Markdown. So we're no longer talking about that bloated HTML with a whole heap of inline styles and kind of ugliness to it. When you're looking at the raw data and behind what's rendered on your browser, converting it to that Markdown, and then we're actually got our own little MongoDB that we can now query locally here. It's just running in Docker. I've got a little Mongo database that I can now query and retrieve those documents back. And then an API created around the outside of that. So if I wanted to, I could also talk directly to my API to pull those documents down. And then within the API itself, there's a regular kind of a cron job, if you like, that's reaching out and looking for new or updated KB articles, and then there's a workflow around that which will go and obviously add any new documents to our database, but if it needs to, it'll go and update any of the existing documents in the database, but it also re-embeds them and updates the vector database with our new vectors, which we'll talk about shortly. So here's an example of what I'm talking about. This is the middle of a Veeam KB article that's rendered on the site. You can see the red boxes here is all the things we want to get rid of. We don't care about all the print icons and the code behind that and the article updates. And then the box at the bottom there is actually a big inline form. And the red dots actually represent something I thought might be quite useful for a further iteration. And so not only when we convert the whole article down to Markdown, I'm actually trying to detect for these headings and I'm putting them into specific parts of the Mongo record as well. So I've got the full Markdown version of the article, but then I'm trying to find challenge and clause and solution and more information. And I've just got those chunks because I thought maybe that might be useful to pass different parts of context to the LLM or render it in the chatbot differently when I've got those separated, which is hard to kind of do if it's all just one big article. And so this is the net result. So not the same article, but you get the idea. The panel on the left here is what, after the scraping engine and has cleaned it up, looks like. So this is the full version. You can see it's got nice little table versions of Markdown and all the headings are nicely done. So there's no interference in the middle here. This is just what it produces on the outside. And then when we render it through just an online Markdown renderer, this is what you get on the right hand side. So nice and tidy. We can now pass this completely to LLM, and it's much lighter, much more lightweight than passing all the div tags and styles and other bits and pieces. So very clean data. And just a quick snap really of the MongoDB. You can see all the various different detailed solutions, MDXs. I'm actually storing the HTML as well in the MongoDB just in case I need to reprocess things or do some analysis, but I'll eventually drop that out. And yeah, any of the MDX fields are the converted fields. And so, where there's nulls, it's just that we couldn't find a heading of that type, but that's largely what it looks like. And then there's a wee API. So I can obviously get a list of KB articles. I can get it by ID, which is useful for when we talk a little bit later in this process, where we've matched that record out of our vector database. And then we want to query our API to get that content back so that we can pass it to our large language model as part of that context. And this is kind of the response we get back. So a nice little JSON response, pretty heavy at the moment, could be optimized, but if you're hitting the API now, this is what you'll get back. And you'll see there's also some handy little products referenced things in here, which is quite handy. If there's a KB article that applies to one or more products, we can then start using that potentially in our chatbot to say, hey, this applies to X, Y, and Z as a separate kind of UI element or interface or button or whatever it might need to be. So it's kind of clean data. So we've got to the point where we've talked about RAG, a little bit about the high level, and we've talked about the good data. And then now that we've got good data in our Mongo database, we need to create embeddings. And so what are embeddings? They're really just a big array of numbers that represent our document chunk or the entire document. So that markdown document gets embedded with an embedding model. And effectively, that allows us to store these embeddings in our vector database and then query them. And the cool thing about embeddings is it is just this big vector space. And so you can see here that the line at the bottom there, embeddings that are numerically similar are also semantically similar. And that's important. So if we take a look at what that means, so this is kind of a flat vector space. You can see up the top right, we've got feline and canine and meow and bovine and moo and woof. They're all kind of represented by, animals in a way, whereas a quarterback throws a football is no way, in shape or form related to an animal. So it's kind of in a different vector space. So then you can see when we start querying that user's query, where it says, are there any quarterbacks on the field or something like that, we would more likely find the item in the bottom left rather than something up the top right. And then we can use those to return back to our code, retrieve the document chunks and pass those on. And so embeddings becomes a really important part of this process. And if we quickly jump off here, this is kind of what the embeddings look like, right? So if I look at here's KB4354, this is my Pinecone SaaS app, which we'll talk about vector databases shortly. But these are the values. This is the sort of information that we're storing in our vector database. And these are the bits of metadata that we're interested in here. And even within Pinecone, you can start querying vector space too, which is pretty cool. So embedded data, as we mentioned, looks like this. And this code here was using the 8802 model. That's moved on, I think, since I put these slides together. That's now a slightly new model. But ultimately, the same thing will happen. So we input that text, so in our case, the whole KB article, not a chunk in this first version, and we get back a bunch of embeddings. So 1,536 of them for this OpenAI model. Some embedding models are smaller and larger than that. I think OpenAI even have some larger ones now. And we get those embeddings back, and then we actually store that big array of 1,536 numbers into our vector database alongside that metadata, because remember, we just embedded KB1234, so we can store that metadata there into our vector database for use later on. So vector databases, we've already talked about them a little bit. Really, they're like any other database. We can put data in and query it and get data out, and we can update records and delete things and do whatever we need to do. They're just really optimized for vector data. So the types of information that we're talking about here around, embeddings. And so there's lots of options. I used Pinecone. You just saw that console. I've also used in version 2 Supabase, which kind of is pretty cool here as well. Like this is kind of I think it's Postgres under the hood, with this vector kind of PG vector kind of shim over the top. However it works technically, I'm not 100% sure, but you can see here we've still got our embeddings on the right hand side, but I'm actually also storing the text chunk that's related to it. So that's kind of changed a little bit in version 2 as well. And so there's lots of them. Some of them are open source, some of them are free, some of them you have to host yourself, some of them have open source models with a SaaS solution you can pay for if you don't want to. Some of them are more traditional SQL databases with, a shim over the top, like that Postgres one we just talked about. And so this space is evolving all the time. This is quite an old diagram now. There's lots more than this, and some of them have different features over others, which might be more applicable to your project. I really liked Pinecone at the time. It was easy to get started. They've got a free tier. I didn't need to set anything up. So kudos to them. And same goes for Supabase. Also, very easy to get up and running. All nice local SDKs and things that we can leverage to do all the heavy lifting of getting data in and out of our code. And so we've talked about the vector DB, so that's a screenshot of it, but ultimately you've seen that in the flesh from that other tab. And so those are the vectors and the ID, and then Supabase. So recapping kind of where we're at, we've talked about RAG, that retrieval augmented generation, where we're able to kind of look up data and pass context to an LLM using different models and techniques and things. And we've talked about clean data in our Mongo database, where we've got a chunk of data that we can then pass back and forth. And we've talked a little bit about embeddings and vector databases. And so now we can sort of start seeing the fruits of our labor. And so this was my kind of app journey. Version 1 was really just a little Next.js React application. It makes queries via the Pinecone and Node client, so we're not using any other libraries, which we'll talk about in version 2. And so from here, we're able to use just native kind of JavaScript code effectively to talk to Pinecone, talk to OpenAI to get those prompts back from the large language model. And so the process goes like this. We embed the user input. So that is the query. So, are Microsoft Loop websites supported? We'll go and embed that. So just like we embedded all of our documents, we actually embed the user's query. That same process with the same model. We'll get those same amount of numbers back, and then we can go, hey, vector database, I've got these vectors. Which one is the most similar? And so that's what we're doing here. We look up and we match the top one in my case. Version 2's moved on from that. And so we just bring back the top match that matches the query the best, and then we pass the KB. We can also go fetch that KB and the question to our LLM, and we get the answer back. And then once we get the answer back, we actually go grab the full KB article in Markdown format, and we render it in a browser, so that the user doesn't have to go off to the Veeam KB website to read everything. They can see the answer that the LLM's produced, and then also the query back. So we take a look at what that looks like. So this was Vanny GPT version 1. So I can say, Microsoft Loop websites supported. And I can click Ask Vanny, and from here, it says, no, currently Microsoft Loop websites are not supported by Veeam Backup for M365. However, support for this feature will be developed once more when it becomes generally available. And you can see I can click View on Veeam and it will take me off there, or I can just scroll down. Because we've got that nice markdown, you'll notice I've put a little bit of a style sheet over the top of that, and I'm able to render that nice KV article in the browser so that we can get it. And then just like any other LLM, you can do fun things like, well, it should do anyway, Microsoft Loop websites supported, and then we can say respond like a pirate. Go ask Benny, and then there we go. We've got the same answer, but it's prefaced with "are matey" and a bunch of other, uh, keep a weather eye on the horizon for updates and future support for these sites. So that's kind of cool, and obviously a fun example. But you could get it to start responding in different ways depending on kind of what you're asking about. So that's version 1, pretty basic now in the grand scheme of things. I felt like it was really, really awesome, a year or so ago when I built it. And it is still kind of cool, but things have moved on, and obviously there's a lot of really neat chatbots out there now. So version 2, I'm not going to show you because largely it's the same kind of thing, but let's talk a little bit about how I iterated on that process. And so again, same kind of backend, Next.js and React. However, this time we're bringing in LangChain. So if you haven't looked at LangChain framework toolkit, really fantastic. There's various different drivers or support for different vector databases and chunking strategies, and so different models, even like local model support. And so go check out that big ecosystem because there's kind of plugins, if you like, being built for a bunch of things on that framework, and it's really fantastic. So that's what this was built on. I also switched up just because I wanted to around the Supabase side of things, so use a slightly different vector database. And then the important thing here is this experiment with different chunk sizes. So in that first version, you'll recall we passed the entire markdown document to the embedding model, and we kind of effectively stored the vector representation of that entire model. However, you think about when you're asking a query, my query might only be relevant to a part of the document. And so, or the document might be really big, is often why we chunk things. And so what this does is I've run a chunking strategy over this to kind of chunk based on those headings, so those sections, and then within that also we can tweak how big we want the chunks to be. So at first it chunks it up by heading, and then within that it'll actually break it up further, so maybe on like paragraph or new line. And so again, LangChain has a lot of those that chunking code built in where we can just pass it some text and it will return us the chunks, which we can then embed individually and then store in our vector database alongside the metadata. So what KV it was, but maybe like what section of the document, anything else that might be relevant, like what page number from a PDF, you name it. And so I experimented with that a fair bit and to see what results I got back. Because when we're dealing with these chatbots, we've only got a certain context window. So a context window is how much data we can kind of push in to it. And so, we might be talking about a 4,000 context window or an 8,000 or Gemini Pro or Plus, whatever, it's got apparently 1 million context window. And so sometimes it's not plausible. You think about we're trying to chat with a really large document or heaps of results back. You'll notice that I'm returning more than just the top match in this one. So I'm actually returning the top 5 matching vectors from our vector DB. That can get really big really fast, and it might not fit in our context window. So by chunking it up and only returning the chunks that the vector database thinks is the top match, we can then reduce our context window around that. And there's a bunch of other things that approaches that we can take in this RAG world now, where we might want to return the chunks and then have an LLM summarize them individually. So that reduces the chunk size further, and then pass the summaries to our LLM along with our original query. And so there's a whole heap of really clever people doing some pretty neat kind of RAG type designs, architectures around that, depending on what your use cases is. Thankfully, the Veeam KV articles are relatively short. The chunk sizes were relevant, so I didn't really need to go much further than chunking them up, returning the top chunks, and then getting it to give us a response back based on those top chunks and hopefully a better answer. But there's definitely an art to it, and it's not a one-size-fits-all thing. Chunk sizes do need to vary. Your content will have a big bearing on that, and so just bear that in mind. Don't just run some code out of the box. Chunk sizes do matter, so experiment with it, see what it's like, and go from there. And then you'll notice on that Vanny GPT-1, we kind of clicked the Ask Vanny question. It'd spin for a bit and then give us our response back. We're obviously now used to having those tokens. That's that token response back from the model returned in real time as it's being kind of generated out of the model itself, and so that did that as well. So that was kind of version 2. An iteration on, just learned a bunch more about chunking and LangChain and a slightly different vector database and returning different numbers of things. It was really about experimenting and kind of moving on, but largely upon the same data set, the exact same kind of output, same model that we were dealing with in the back end too. And version 3 was really all about function calling. And so kind of throughout this progression, functions came along. And so I think June last year, OpenAI released their model. The 3.5 Turbo model was going to support functions. And so I genuinely think this really is a new way of us interacting with our infrastructure. You imagine being able to talk to an upstream system that's got live data, not just KB documents or PDFs that are sitting on our file servers. Talk to a Veeam backup and replication server, for example, via natural language. Obviously, they've got APIs that's presenting real-time data at the back end, or maybe we want to bridge a backup and replication server with a ServiceNow, and start logging tickets because a backup job's failed. We could genuinely change the way that we interact with systems using large language models themselves. And so functions, kind of as defined here, are really code that the LLM can request to be run within our application. So we have to still write the integration. The large language model can't trigger the API for us. We still need to trigger the API and get the response back, maybe manipulate it a bit, reduce the data to make it a bit more efficient. And our application will fundamentally run that. But when we ask the query of the LLM, it'll say, hey, you've said that these tools are available. I would like to trigger that one, please. And maybe there's some input parameters as well. And so that's what we're doing here. And you can't just, you're not really limited to just reading data out and go and give me a report of the backup jobs that have run. You can actually get it to trigger jobs too. So we'll have a bit of a play with that in a second. And so, yeah, really there's endless possibilities. You can integrate any block of code. It doesn't need to be just talking to APIs. You could have just a simple little function within your code that doesn't reach out to any external system and just performs a calculation. But yeah, I think the true power is in being able to bridge these LLMs with various different system APIs and have us talk and just make our jobs a bit more efficient, give us different response, get it to gain insights into the data that's there that maybe we can't see too. So let's have a look at Vanny GPT 3-ish, and this is kind of what he looks like. And so I can say, here's some pre-canned questions I've got in here, so I don't have to type them out, like what backup jobs do I have, list them and provide a total count. If I click go here, you'll see it spinning and you'll see, okay, cool, here's some backup jobs. This one's disabled, the K3's job's enabled, and that's all good. And so if we look at some of our code, so this is our chat with BNR bot that we were just looking at, and so down the bottom here we've got these tools. So when we when we're talking with the large language model, along with our query, we'll also say here's some tools that you can use if you need to. It doesn't need to use them because we might just ask a question and it might be able to just give us the answer back, just like you're chatting with ChatGPT today. But if it thinks based on your query that it could leverage one of the tools that you've given it, such as get backup jobs in our case, where we just said, what are the list of the backup jobs, then it will. And I've also given it a backup job state, start backup jobs. This is where we're starting to write in. You'll notice that this takes an argument of ID. And so you can see these get quite complex, but I've just said it needs an ID. And so it will leverage these tools and it might look for an ID parameter and get backup jobs, and then it will work out that it needs to insert that into here, and our code will take care of that and trigger things. So if we go back up and look at, say, this one here, this is where we get our jobs. So this just looks, pretty basic. We just go and fetch our jobs endpoint, which is just a local backup server that I'm running here with obviously our authentication token. And then when we get it back, we're actually getting a whole bunch of data back, but all I'm doing is pushing the ID, the name, and the status. You could expand that for any other information that you might want that's in that payload that's coming back from the Veeam server, and inject it into your job list, and then the LLM would then have access to that information. But this is an example of where we've maybe got a bigger payload coming back and we're reducing it down in size to just keep it kind of under control in terms of the amount of data that's being passed back and forth from the LLM itself. And if we look at the backup server, you can see here's a bunch of jobs. We've got nothing running. And so if we go back to our thing here, let's see if we can get it to play ball. It's not always accurate, but I could say, is there a K3S job in our backup server? Oh, great. So it's detected that there's one K3s, and then we could say, what is the ID of this job? Cool. So it's returned an ID. And then what we can say here is like, can you start the job? And what it's working at here is you can see that just by naming it, it's worked out the job out of that list of jobs, because there's no like query by name API. So it's returned all those jobs back, and it's worked out that the one that's named similar is the one that we want to use. It also, you notice I haven't said what's the ID of the K3's job. It's already looked at the context that we've previously talked about here, and then it's able to infer the ID from that. And then I've said, can you start the job? Again, I haven't said, can you start the K3's job? But you'll notice that one K3's backup has been started successfully. And then I could say, like, are there any job sessions running? Yes, there's one job. It's working. It's our one K3's job. That's good. This demo is working brilliantly. Creation time, and just to show there's no smoke and mirrors, you can see that the one K3's job is now started. And so obviously a pretty basic example and not fully fleshed out in terms of all the other API endpoints, but I think you can kind of start to appreciate the power of this, of being able to bridge multiple systems together through the power of natural language. And yeah, I would love to kind of iterate on this more, and I intend to this year. But yeah, coming back to kind of where we're at, there's endless possibilities with this stuff. You combine the KB article things with this function calling, go in and query your backup jobs and find any warnings or any error messages that might be popping up, and then getting it to query the KB database, give it that tool as well, so it can then go, hey, are there any known KB issues with this type of error? And I think you think about how we work today and try and bring that into a single interface or as close to that as possible. And I think that'd be a fantastic spot to be, particularly if you've got disparate infrastructure. So that's kind of where I'm at with LLMs, and I really hope that at least some of this has been useful into the kind of insight of how these things are constructed. But I would kind of finish off by saying, look, this stuff's easier than you think. There's lots of examples out there. Frameworks like LangChain make it incredibly easy to get started and kind of get hacking away. And so yeah, my advice to anyone wanting to go down this path is pick a data set that's already out there or available, or an integration that's already there. Maybe look at LangChain first, because there's readers for various different storage systems, even things like SharePoint or file servers. All that chunking code's there. Go through and look through those Git repos. There's some really good examples out there around getting started, and then just start with stuff and see where you fall. But I would say that it's kind of like a once you pop, you can't stop. Yeah, it's been a bit of like a personal addiction of mine is to keep learning about this stuff. And yeah, as I mentioned, I'm going to continue that for hopefully a long time yet. And it's an exciting space to be in. So thank you for putting up with me. I hope you found that useful. And yeah, if you need to reach out, Ben Young NZ on Twitter. Always happy to answer questions or yeah, provide advice around my own journey. But there's yeah a lot of smart people out there doing some pretty cool things that are publishing code and documents and things too. So have a look around and see what you can find. I'm out.